Hey Siri.
Hey Aubrey, you need to teach basic calculus.
So what's up? It's your boy Aubrey. A pleasant day, everyone. I'm here to teach you about basic calculus. Are you ready? Let's begin! So guys, for today's tutorial, I'm going to teach you about higher derivatives applied in logarithmic and exponential function. But before everything, what is higher derivatives? The derivative other than the first derivative are called higher order derivatives. In other words, if the function f of x is given, the second derivative is this, then the third derivative is this. So, they are called higher order derivatives. Aside from higher derivatives, we also had logarithmic and exponential function. So guys, here are the formulas that we are going to use. Formula for exponential function. Formula for logarithmic function. Now, let's proceed to the examples. For example number 1, we have e raised to sine 3x plus 5x. Since we are using natural exponential function, we need to use the formula e raised to u times the derivatives of u. First, we need to find the derivatives of e raised to sine 3x by using the formula. EU stands for e raised to sine 3x, then multiply it to the derivatives of u. The derivatives of u is cosine 3x times 3. After that, we need to find for the derivatives of 5x. The derivatives of 5x is 5. Now, we need to arrange the position. Our first derivative answer will be 3 e sine 3x times cosine 3x plus 5. For the second derivatives, we need to find first the derivatives inside the parentheses. Since we need to multiply it, we will use the product rule of derivatives. Before that, we need to move out first the number 3. So, 3 times open parenthesis, then apply the product rule. Cosine 3x times e raised to sine 3x times cosine 3x plus e sine 3x times negative sine 3x times 3. For the derivatives of 5, it is 0. For our next step, add it and arrange its position. So it will become 3 times open parenthesis 3 e sine 3x times cosine squared 3x minus 3 e sine 3x plus sine 3x. For the last step, just multiply the 3 inside the parentheses. So it will become 9 e sine 3x cosine squared 3x minus 9 e sine 3x sine 3x. To get the answer, just simplify it. So it will become negative 9 e sine 3x times sine 3x minus cosine squared 3x. For example number 2, we have ln sin x. Since we are using the natural logarithmic function, we need to use the formula 1 over f of x times the derivatives of x. By applying the formula 1 over f of x times the derivatives of f of x, it will become 1 over sin x times the derivatives of sin x. What is the derivatives of sin x? The derivatives of sin x is cosine x. Now, we need to multiply the numerator. Cosine x times 1. So, it will become cosine x over sin x. Guys, we need to simplify it So our first derivative answer will be cotangent x. Guys, we need to remember the rule of quotient identities in trigonometric function, which is cosine theta over sine theta is equal to cotangent theta. For our second derivatives, just simply find the derivatives of cotangent x. The answer will be negative CSC squared x. So our second derivative's answer will be negative CSC squared x. For our last example, we have ln 3x squared minus 7 raised to 4. So guys, like the example number 2, we need to use the formula 1 over f of x times the derivatives of fx. Now, by using the formula 1 over f of x times the derivatives of fx, it will become 1 over 3x squared minus 7 raised to 4 times 4 times 3x squared minus 7 raised to 3. Since we need to use the chain rule, we will find the derivatives inside the parentheses. So the derivatives of 3x squared minus 7 is 6x. Now, we need to multiply the numerator. 1 times 4 times 6x times 3x squared minus 7 raised to 3, it will become 24x times 3x squared minus 7 raised to 3 over 3x squared minus 7 raised to 4. By simplifying it, our first derivative answer will be 24x over 3x squared minus 7. For the second derivatives, we just need to apply the quotient rule. So, 3x squared minus 7 times the derivatives of 24x minus 24x times the derivatives of 3x squared minus 7 over 3x squared minus 7 squared. We need to multiply it first before subtracting it. Now, it will become 72x squared minus 168 minus 144x squared over 3x squared minus 7 squared. Then, it will become negative 72x squared minus 168 over 3x squared minus 7 squared. So our second derivative's answer will be negative 24 times 3x squared plus 7 over 3x squared minus 7 squared. So guys, I hope you understand on how to solve higher derivatives applied in logarithmic and exponential function. So if you want more videos, just click the notification bell and subscribe. Thank you!